Okay, good morning class. So today we're looking at probability. At this point we have completed our Venn diagrams and our tree diagrams as well. So now today we're going to look at two-way tables. Okay, let me just check out. Spoke about the two-way table. So we're looking at the examples for exercise 12.6, correct? 12.6 on page 417. And I'm reading from page 415. Okay. So now we're looking at two-way tables for independent and dependent events. Remember, we said that dependent events is an event that is when you are doing a second event, where the second event is dependent on the outcome of the first event. Okay? So we already spoke about when an event is independent and dependent. You can refer to our previous lesson as well. Also, there's full lessons in the description box below. Okay. Importantly, at this point, we worked on a formula which is for independent events, the probability of A times the probability of B is equal to the probability of A and B. Okay, we spoke about that extensively. Okay, I think in the previous video, the lesson before that. So now we're looking at two-way tables, and we're told that the two-way table display the number of outcomes of each event. The various probabilities can then be calculated from the information in the table. In these examples, we will look at the data rather than the probability experiments. Let's look at example 1, and example 1 is on page 415. So here we are told that 100 people were asked which season they preferred, and the information was entered into the accompanying two-way table. So the question was who liked summer and who liked winter. We have females and males as well, and the totals of course is given. Importantly, at this point we should know that 20 plus 30 gives you 50, 39 plus 11 is 50, 39 plus 30 is 69, that is going to give you 20 plus 11 is 31, and 50 plus 50 is 100. There were 100 people in total that were surveyed. Okay, you guys understand? So any confusion thus far? Alright, so the first question says, determine the following. A, the probability of being female. If you're selecting a person at random from this group of 100 people, what's the probability of it being female? How many females are there? There are 50 females in total. Not so it's 50 over 100, which is? Oh, so it's 50-50. Wow. Okay. B. Male and likes winter. Male and likes winter. So how many is that? 11. You guys understand? So male and likes winter, so it's 11 out of 100. And that's in the simplest form. Let's look at C. Female and likes summer. Female and likes summer. It's going to of course be 30 out of 100, which is 3 out of 10. Okay, do you guys understand? Is there any confusion there? Normally a question that accompanies this, but it's coming probably in the next example. I don't want to give you too much at once. Determining whether events are independent. Okay, and remember, for independent events, whenever you read independent events, this should come to mind. Okay, the probability of A times the probability of B will be equal to the probability of A and B, or A intersection B. Okay. Whenever you see that word, that should come to mind. Okay. So determining whether events are independent or dependent. If A and B are independent events, then the probability of A and B is equal to the product of A and the probability of A and B. Conversely, which means to say in the reverse, if the product of A and B is equal to the probability of A times the probability of B, then A and B are independent events. Okay? So that's basically the reverse of the rule. So if they tell us that the events are independent, then the probability of A and B is equal to the probability of A times the probability of B. However, if they ask us to prove that the events are independent, then we prove this formula actually works. You guys understand? So if they tell us it is independent, then the formula is applicable. If they tell us to prove that they are independent, we prove that the formula works. Okay? Well, the formula is equal. That identity is equal. So let's see here, example 2. So example 2 is on page 416. Example 2 is on page 416. So here we are told that 90 people were interviewed on whether they preferred sweet foods or savory. You guys know what sweet foods are, no? Donuts and those things. And savory, the samosas and those things again, and pies and stuff. Okay. The problem with me is both is my favorite. Okay, so that results in how I do today. Okay. But anyway. And the results were recorded in the following two-way table. So we got male. So we got male, 55 males were surveyed and 35 females were surveyed. Okay, those who like savory is 33 plus 21, which is 54. Those who like sweet is 22 plus 14, which is 36. And the total, of course, is 90, and the total that way is also 90. That's why if they leave out this value here, I can then say 35 minus 21 will give you that value. You guys understand? That's how the two-way table works. Okay. It's also known as the contingency table, but I don't see that word coming up in this textbook. So for you, two-way table is suffice. Okay. So determine the following. The first question says the probability, calculate or determine the probability of you selecting a male. So what's the probability of selecting a male? 55. So it's going to be 55 over 90. And 55 over 90 is? Just get the calculator here, probably need it later. Let me give you 11 over 18. You all agree with that? Let's look at B. B says the probability of the person selected at random prefers savory. And how many savory is there? 54. So it's 54 out of 90. So it's probably 6 over 10, which is 3 over 5. Let's check. 54 over 90. Yeah, 3 over 5. Okay, is there any confusion there? Okay, let's look at C. So the condition is male and savory. Okay, so the probability of male and savory. Okay, let's make it SV, because the sweet is also there. Okay, male and savory. There is no mark allocated for what you write here. Okay, so male and savory. So it's male and savory, which is 32. 33. You all agree with that? So it's 33 over 90. Okay, and 33 over 90 is 11 over 30. Okay. Let's look at D. D says The probability of male times the probability of savory. So people, if the probability of male and savory is equal to the probability of male times the probability of savory, then what can we conclude? The events are independent. Not so. So let's look at the probability of male. We worked that out already, which is 11 over 18. Times the probability of savory is 3 over 5. So let's see what that gives us. So that is 11 over 18 multiplied by 3 over 5. Gives an answer of 11 over 30. Which is the same. So the events are independent. So E. Does the data collected from the survey shows that food preferences are independent of gender? The answer is yes. So we answer that. We say yes. Since the probability of male intersection savory, that's a B, is equal to the probability of male times the probability of savory, which is equal to 11 over 30. Okay? Therefore, events are independent. There is no ID. Yeah, the events are independent. Okay, you guys understand? Right. Let's look at example 3. Example 3 is on page 416. Pause here quickly. And I've cut it already. Okay, sorry about that. So let's look at example 3 quickly. Here we are told that 80 learners, and this is on page 416. 80 learners in grade 11 were asked whether they played sports with the school, and the results were recorded in the following 2-8 table. So we got males and females. The total number of males in the survey is 30 and females is 50. Play sport, the total is 48. And don't play sport is 32. And the grand total of the people surveyed, there are 80 people in total. First question, determine the following. The probability of being female. The person chosen at random is female. The probability of female is 50 out of 80, which is 5 out of 8. B. Play sport. So play sport. It's going to be, you see they didn't specify male or female. So I'm going to go with sport. 48 out of 80. So 48 out of 80 gives us 3 over 5. Okay, let's look at C. Probability of female and play sport. Female and play sport. 21 out of 80, and I think that's in the simplest form, no? Okay. Let's look at D. The probability of female times the probability of play sport. Okay, sport. Alright, so female would have been 5 over 8 multiplied by play sport, which is 3 over 5. That cancels not, so leaves you with 3 over. Is that correct? Okay. Let's look at E. E says, do you think that sport preferences are independent of gender? The answer, the question is, why or why not? So what do we know? How do we calculate for independent events? So how do we test? We need to prove that the probability of A times the probability of B is equal to the probability of A intersection B. In this case, it's not A and B, of course. So we have female and sport. There's going to be female and sport. Did you see that? Now, if you look at the previous example, if we managed to prove that that was independent events, not so. So if we go with male and play sport or do not play sport, which is 3 out of 50, and then we work out the probability of male, which is 30 out of 80, and don't play sport is going to be 32 out of 80. If we work this out for female and play sport and it's independent, then that means to say whichever way on the table I calculated, it will remain independent. Conversely, on the other side as well, if we prove that this is the case for female and play sport is dependent or not independent, then any way I work it out will always be independent. You guys understand? So let's take that into account. Since we already know the probability of male and female and play sport, so I work this out now. So it's going to be on the left hand side of the equal sign. So it's going to be probability of female times the probability of play sport. We've worked this part out already, not so. It's 3 out of 8. Is that equal to the probability of female and play sport? So female and play sport is 21 out of 28. So is that equal? So it's not equal. Therefore, events are not independent. Or we could have just said they are dependent. Do you guys understand? Yes. And that's how easy this two-way table is. Okay. So with that, you should be able to do exercise 2.6. 12.6. Alright. I'll stop the video at this point.